All right, welcome. I am Ryan Holger with TEC. I am going to be your tour guide for the next hour and 5 minutes because I always go over. Never once have I not gone over. Uh, if you have questions as we go, type them in the chat box. I'll try to look at those. There's almost 200 people on here this time around, so it might be a little bit tough to read them all, but I'll try my best to check them out. For you guys that need PDH hours for continuing education for professional engineers in Illinois and Wisconsin, there's going to be quiz questions that come up. You have to answer the quiz questions correctly in order to get PDH credit. Everyone else is certainly welcome to answer the questions. I encourage you to do it, but the guys that need the credit have to do it. So let's make sure you pay attention to that as we go so I can stay within the rules and nobody gets in trouble. All right, so there's our agenda today. We are going to be covering some of the refrigerant changes that are coming up, equipment efficiency changes, a little teaser on code updates for Illinois specifically, and then just to make sure everyone's on the same page with the rebates that changed 2 months ago. So here we go. I want to click. What the hey? There we go. So very first quiz question, starting off right away. Most of these are easy. This one is super easy. You cannot get it wrong, but you do have to answer it. Do you need a PDH certificate? Yes or no? There's no wrong answer, but not answering it will penalize you for getting the questions right. So please go ahead and do that right quick. We won't take very much time to do that one because you shouldn't have to think about it. All right, 59% of you answered. I'm going to give it like 10 more seconds, and then I'm going to close it. All right, closing it in 3, 2, 1. All right, so 45% of you do need that certificate. All right, moving on. So refrigerant updates. Here's kind of a quick summary of all of the things that, so I'm a little ahead of schedule. It's telling me it's 1:30, time to do my webinar, but I'm already doing my webinar. Okay, so all the things that are coming up refrigerant-wise. Some of them have already happened, like the first couple ones there. Obviously, R22 production has ended, and R123 production for new equipment has ended. There's a difference there. One of them is they can't produce the refrigerant anymore. The other one, they cannot produce equipment that uses that refrigerant anymore. So those two are both things that both happened a couple of years ago. Obviously, you can still get R22 refrigerant at supply houses. It's just that no one can manufacture any new refrigerant. So they either have to have had it stockpiled or it can be reclaimed and cleaned up, professionally cleaned up, and then redistributed somewhere if need be. But that does cause volatility in refrigerant prices. R410A and R134A, for that matter, are the next ones that are on the chopping block. Actually, all HFCs. So the next date that comes up for those guys is the end of 2023. We will no longer be able to have R134A or 410A in any new chillers. It doesn't affect residential or rooftops yet, but chillers will not be able to use those refrigerants anymore, and they have to migrate to a different refrigerant that has a lower global warming potential, which we'll talk about here in a minute. The year after that, R410A and other HFCs, which would include 134A, we just don't have it in any kind of equipment like that, would be out for all equipment, right? There's, I think, 12 states that are set up that way. So it's a pretty good portion of them, and they're typically the states that are bigger users of HVAC equipment. So once that happens, it's the rule for those states, but it'll kind of automatically just happen for everybody else because they're not going to build two completely different lines. I mean, they will for a while, but it's going to kind of kill off the old stuff. All this time, production of R410A will be being decreased by law, so it makes it harder to get some of this stuff. The end of 2024 is also the end of R410A in unitary equipment. So we won't have it in chillers in 2023. We won't have it in unitary, which means rooftop units in 2024. So that just leaves a few different kinds of products left, so it'll slowly trickle out for everybody. The end of 2029, our 123 production ends. So it already ended for new equipment to be built with R123, but you can still get the actual refrigerant until the end of 2029. And then also at the end of 2029, oops, a little further ahead of myself there. Let me hide this thing on the side so I can see better. trying to keep all these windows open so I can see questions at the same time, but it's hard. We'll have the end of 134A and 410A and 407C and all the other HFCs. So you got, what does that leave you? 8 years. If you're retiring in the next 8 years, don't sweat anything. Everybody else got to pay attention. The main driver of all this is the global warming potential limits instituted by certain states and or federally. The big target is 750 maximum global warming potential. So some refrigerants will be able to handle that, some won't. R410A is up here at 2088. So it will not be permitted when these new metrics kick in that we're talking about. Some of the common ones that have been mentioned for usage, R32. A lot of manufacturers are already using it for certain things and will continue using it for other things. It is only a 675 global warming potential, which will help it stay alive until basically 2029, and then it's going to struggle again to be compliant. And then R454B is a popular one, which only 466. That gets us all the way to 2036 before we got to pay attention to a change again after that. And there's some other ones that manufacturers are using as well. The big thing with all of these refrigerants is that they have a different type of flammability than most of us are used to in the past. So this table here comes out of the ASHRAE standard. There's two refrigerant standards, ASHRAE 15, which is refrigerant safety, ASHRAE 34, which is refrigerant classification. So on the classification standard, let me get some kind of arrow or something on here. There we go. So for those guys, we've always had the A's, which are low toxicity refrigerants, and the B's, which are higher toxicity. We try to do most of our comfort cooling stuff with the low toxicity stuff. And then we've had the 1 category, which is this horizontal one here, no flame, and then 2 meant flammable, and then 3 meant higher flammability. What we've squeezed in there in between now is this A2L and B2L. It's technically flammable, but it's a lower flammability than the flammable is. So essentially what that means is it can burn, but it's very difficult to ignite. You need a very large energy source to ignite it. So it's not likely to burn in most scenarios. So it's safer than the orange ones, but not as safe as the green ones as far as flammability goes, essentially what it is. So some of these kinds of refrigerants that we're using now today are R410A, and one of the major ones we're switching to, R54B, are blended refrigerants, as you probably well know. And R32, which is the other refrigerant I mentioned a minute ago, is part of those blends. All right, and then it gets blended with something else. So these guys are all pretty much mixes at this point. Everything in the 400 series of refrigerants is a blended refrigerant. As mentioned, the flammability is the big difference there, and somewhere around here it'll probably say it right here. So these A2Ls, they're difficult to ignite. They require a lot of energy to do that, so they're not going to light accidentally because of something that happened. Like in the examples here they gave were a pilot light or static electricity igniting it. That won't be enough energy. You'll need more energy than that to ignite it. So it's not likely that you'll have an issue. So that's kind of what's coming down the pipe there. As far as what we're doing for Carrier and obviously Bryant and ICP type products and stuff like that, some of this has already started happening, by the way, because chillers is coming up quick. We got to obsolete R410A really soon. So for the scroll chillers with R410A, the replacement refrigerant is going to be R32 because it has a lower global warming potential, as mentioned earlier. The big stuff with 134A, so the 19 series chillers, the 23 series tri-rotor screw chiller, those ones are switching to 513A. It has properties that are similar enough to 134A that it'll allow the reuse of certain components when they manufacture these, not all, but some. We meaning TEC, can already select chillers for you with this refrigerant, so you get the performance data. So you could have our sales engineer that you're working with give you a selection using 134A, and then for the similar machine, give a selection using 513A, because you may be doing the project this year, or maybe you're designing it now, but it's not going to even get purchased and installed for like 2 more years. So you may want a 513A selection to base your design off of. For smaller stuff, light commercial rooftops, as well as residential, I saw we had several residential folks logging in here, so this applies to you as well. Carrier and Bryant are switching to 454B as the refrigerant choice because it has a very good global warming potential. And in the case of those products, they're being completely redesigned around the refrigerant, so it's much easier to switch to a newer refrigerant. And then we've had this chiller, the 19DV, for I want to say 3 years ago it came out, and it has an excellent global warming potential of just 1. That's not 10, that's 1.0. So it's fantastic as far as being environmentally friendly goes, way better than anything else that we've ever had. But it's a very special machine that we only see a couple of them a year because it's a super niche application. And it's really expensive for this refrigerant as well. That's kind of what's on the plan for refrigerant stuff. All right, let me get quiz question number 2 up for those that are playing along, and then I will look at the question box from you in a minute. Where is it at? Oh, there it is. Okay. All right, quiz question number 2. The final phase-out date for all HFCs, R410A, 134A, R47C, etc. Not the equipment phase-out date, but the phase-out date for the actual refrigerants themselves to be produced. All right. Questions that came up. Steve said you did not get a chance to answer the PDH question. So that question will come up again at the end, Steve, and you'll be able to check the box then. I'll make sure we get you your PDH certificate. Someone asked for a copy of the presentation. If you send me a note at some point, I will get that over to you. I will probably completely forget to do that now. So send me a note, and if you need a copy of these, I will send them to you. All right, 71% of you have answered. I'm going to wait 7 more seconds, and then I'm going to close this question. Once again, if you need PE certificate, you have to answer the question. For everybody else, it's optional. Closing it in 3, 2, 1. Awesome. 93% of you got the correct answer, which is the end of 2029. All right, moving on. Let's talk about some of the equipment efficiency changes that will be affecting your life now or in the near future. Let me get this question screen out of the way for right now. So the Department of Energy, well, first let's say this. There's a movement in our entire country and arguably the world to make things more and more and more efficient so we use less and less fossil fuels. I think everybody's probably aware of that at this point. The way we handle that in the United States is by a minimum of 3 different mechanisms. We have the Department of Energy efficiency standards, which is dictated to the manufacturers of things that they have to be a certain minimum efficiency level. It doesn't generally affect your life, on the installation side, design side, until the thing you wanted to use is no longer available and you got to make adjustments, right? So Department of Energy polices things down at the manufacturer level. Then we have energy codes, which for most areas are policed at the state level or implemented at the state level. In some places, it's more pinpointed than that. So we have energy codes that come into play. And then we have utility incentive programs. All 3 of those things are trying to do the same thing, which is drive down energy use, and they're attacking it from multiple different angles. So right now we're talking about the Department of Energy schedule. So this is the rules that the manufacturers that make things have to comply with. So the most recent one that we just had was last year. Small boilers, which would be 299,000 BTUs and under, so residential and light commercial boilers, bumped up their efficiency. So the minimum efficiency went from 82 to 84% for hot water, and then up to 82% for steam. So that already happened. If you or we still have one of those boilers in stock, we can sell it to you and you can legally install it. It's totally fine. But the manufacturer of the boilers can make no more of those models. They have to only make the more efficient ones. So the DOE rules, generally, you can install those things even if it's after the date. You just can't make any more new ones. The next change is coming up. There's a whole bunch of them on here, right? All the end of 2023, which is faster than you know it. And most manufacturers are being affected by the refrigerant changes and these Department of Energy rules simultaneously. It's 2 different entities. They have nothing to do with each other, but the rules happen to be similar in timing. So most manufacturers are tackling both of those as one, product redesign project. But there's a lot of changes here. So small AC systems, which would be 65,000 BTUs and less, so 5 tons and less essentially. Split systems and package systems have a new minimum efficiency coming. I made an error in this slide and I forgot to correct it. This is not nationally. 14 SEER is what we have to deal with here in the northern half of the nation. Down south, it's different. I'll briefly show you that, although I don't think any of you are from down south, so you don't care. This is a typo here. This is not a national number. Actually this number, or even it's this number nationally, I guess, or more strict if you're in the South. Same with heat pumps. They follow along with this with the AC systems, higher efficiencies there. That is national. They got to go to 15 SEER minimum on the heat pumps and 8.8 HSPF. For those that don't know, HSPF is like SEER for the heating side of a heat pump. On bigger stuff, for example, packaged rooftop units, there was a 30% increase requirement in IEER, and that was split. So 15% of that was, the deadline was 2018, and then the other 15% of that is 5 years later, which is 2023. So we're ready for that next 15% bump in IEER. IEER is part load efficiency. Also at that same time, the gas efficiency minimum is going to increase, although it's only going up to 81%, which is not very difficult to do. So that should not be very challenging for most manufacturers. That should be an easy one. And then also the same date, but for some reason lagging by 9 days. I don't know why they do that. Actually, I know why they do that. It's based on, it's X amount of days after the date they adopt it. And for some reason they adopted that one 9 days later than all the other ones. But commercial boilers will have to increase as well. So we already did the residential boilers. Commercial boilers will go up as well. So they'll have to go up to 84 or 85% depending on the size range of the boiler. And then that's not all. It keeps going after that. There'll be updates to furnace fan efficiency, which we had some updates 3 years ago, I think it was. They'll be on the docket again. Three-phase AC. So right here, these small AC splits on this very top line. That's just for single phase. 3 phases 2026. Then some of the niche stuff like hotel PTAC units, vertical package units, water source heat pumps, they go up. Then the larger rooftops and splits go up, and then this whole cycle repeats again. And it just constantly goes on like that. So they publish the new rules, they get feedback on them, they tweak the rules, they publish them, and then they go live essentially. That cycle just constantly goes. So for the small stuff, mostly guys that are residential would care about this, or if you're putting in split system, single phase stuff, or you have some small rooftops like 3-4 ton stuff. So the current is 13 SEER minimum. The new one in 2023 will be 14 SEER minimum for where we live. We live meaning Illinois, Indiana, Michigan, Wisconsin, Minnesota, where most of you guys are from, Missouri, Kansas. If you're further south, then you have a different set of rules, which is significantly more confusing and complicated. But the north is easy. 13 SEER goes to 14 SEER. If you are in the south, like Georgia, for example, you are already 14 SEER. And then now you have to go up to either 14.5 or 15, depending on the size of the unit. Not confusing at all. And if you're in the Southwest, it's already a hodgepodge. You have multiple rules for sizes, and you have to do SEER and EER, which is full load efficiency. And then you have a different number for small rooftop units. So those numbers also are being carried over, and those get adjusted as well. The full loads don't change, only the part loads do. And that's a general theme you're going to see. We saw it on the rooftops as well. IEER increase, which is part load. Generally speaking, for cooling stuff, the full load efficiency requirements are probably never going to really go up again because we're kind of capped out. Like, generally speaking, the whole country wants all the things they replace to fit in the same place the old thing fit. And the best way to get a higher full load efficiency is to get more coil surface area, but nobody wants that. So we're dictating everything on part load efficiency, which means we can do it with ways other than surface area. Fan speed control being, a big one of those. So all those are changing. Then to make it more complicated, not only do we have to go to these higher SEER ratings for these small tonnage stuff, but the way the small tonnage stuff gets tested for AC and heat pumps is also changing. So today, everything is tested on 0.1 external static pressure. That's like almost nothing. That's almost zero airflow, right? That's almost nothing going on. It's not real. So the new standard will require it be tested at 0.5 external static pressure. That means something that was published at a certain energy rating now will have a much lower energy rating after it goes into the new test because they're testing it with more static, which means more fan speed is required to overcome the static, which means that it's going to use more energy. It won't use more energy when you install it in the building, right? Because it's going to use whatever energy it needs to get down your crappy duct system. But as far as the test goes, it's going to look different on there. So that new standard, to avoid confusion, there will still be confusion, but to try to avoid confusion, Instead of SEER, it'll be called SEER 2 or EER 2 or HSPF 2. So that 2 appendage on there means it's tested with the 1/2 inch external static pressure, and the no 2 means it's the old obsolete standard with the 0.1 on there. So because of that, manufacturers are being required to change some of their equipment to become more efficient. So not only are we going from 13 to 14 SEER, but we're going to the new rating. So when all that gets kind of cobbled together, what we technically have to do is we have to meet 13.4 SEER 2. We don't have to actually meet 14 SEER, 13.4 SEER 2. But 13.4 is not just 0.4 better than 13. It's a bigger leap because of the pressure. And the same thing with all these other ones. Generally speaking, as I said, all the Department of Energy stuff is policed at the point of manufacture. So if something's made before the cutoff date, you can still install it the next year, right? Until your building code locally changes. One exception to that is AC and down south. Down there, it's based on the date of install. But since none of you guys live down there, it doesn't matter unless you retire and move down there, or semi-retire and move down there. If you retire, you don't care either. So for Illinois, Indiana, Wisconsin, Midwest, Kansas City, all of that, it's based on the date of manufacture for all of these things. You can still install it after the date, as long as it wasn't built after the date. The changes are going to be pretty substantial. Yes, we have a pretty good increase, 7-8% in SEER compared to the current legal minimum, and that doesn't sound too bad. However, it is going to affect 70% of the current product lines on the market for AC and heat pump small split systems. 70% of them do not meet the standard. So that tells you how many things currently are in the 13, 13.5, 14, ish SEER range now, and they're not going to meet it, and they have to be basically abandoned or gotten rid of, and something has to replace them. Additionally, everything has to be tested under the new SEER rating. So 70% of the product lines go away, meaning you only keep 30%, and 100% of them have to be retested under the new standards. So the refrigerant topic combined with this Department of Energy topic means giant changes for small split systems. Just briefly, and each one of these things could be its own webinar, but just to give you an idea where some of the efficiency is coming from, there's some improved coil performance. There's the new V-coil, evaporator coil that we have. Many of you on the residential side have probably installed one of these already. We bought like 3,000 of them back in the spring to kind of be the first ones using them. So many of you probably have received them on projects. And it's kind of cool. I mean, it's weird. It's like an A-coil upside down. But because everything is going down like that, the drain pan is like this skinny little slot on the bottom. It doesn't take up much space, so it's not very airflow restrictive. And what we need is an evaporator coil that's not very airflow restrictive, because that's going to help us not have to run at a higher fan speed when we're testing out the efficiency of the equipment. So that V-coil is going to be pretty key as the next year evolves here. There are changes on the furnaces as related to cooling as well. So the variable speed furnaces, nothing really is going to happen there. Those are fine. There's a lot of flexibility on those. But your more entry-level type furnaces, those will be switching to something like this. This is what Carrier is doing. Other manufacturers may do it a different way, but they're switching to an 18-speed furnace, where you have a button where you can toggle through and pick the speed that you want. They need more speed flexibility options because they have to test it at these higher pressures, and things are going to be operated over a different kind of range than they happen to have been operated in the past. So they need more speeds available to them on the furnaces. And then similar stuff is happening on fan coils, switching to a higher efficiency coil there, because obviously with a fan coil, you're not going to put a evaporator coil on it separately. So they have to make those guys more efficient as well. For a rooftop, which most of you guys on the call are commercial, so this is probably more interesting. As mentioned, we already did the first 15% hit in 2018. Now we're going up the last 15%. I say last, but there was always something else coming along the line on that IEER rating, and then a little bit on the gas efficiency improvement. So the reason why we're focused on part load instead of full load is essentially full load never happens in real life. I mean, it just doesn't. If you perfectly designed a system so it exactly matched the load of your building, which nobody does, everybody oversizes. But if you did that, the EER test is done on a 95-degree day. So when it was 95 degrees outside, which is hotter than a normal day in Chicago, that's when you'd be at full load. There's almost no run hours there. Like, it hardly ever happens. It's a couple blips a year. Whereas These hours where it's 65, 70, 75, 80, 85 degrees outside, those are where I spend all my time running. Each one of these bars here is these lines is 100 hours of runtime per year. So just on the 60 to 65 line, we have almost 900 run hours at just that 5-degree band, right? So you start adding all this up, and all the time is spent at part load and almost nothing at full load. So essentially, we've all concluded full load is almost irrelevant. So part load efficiency is where the action's at. And that's why this Department of Energy standard doesn't even talk about full load. EER, there's no minimum EER. There isn't. It's only IER. That's all that matters, part load. You can be horrifically inefficient at full load, but it doesn't matter because it only happens 10 hours a year. Obviously, if you get some kind of process thing going on, that's different. But the way the IER rating works for rooftop units and large split systems, they essentially rate the unit at 100, 75, 50, and 25% capacity, and then they weight those averages, with a big portion of it being on the B, which is 75% run capacity. So 61% of the weighting factor goes on this run point. 24% of the weighting factor goes on that. So pretty much all the weighting is going on the 50 and 75 point runs. Almost nothing, 2%, goes on the full load. And then down at the bottom, not very much either, because at that point, a lot of projects are already in economizer mode. So it's not that exciting to be efficient there. So basically running it at these points here. So just to kind of let you visualize it for the different sizes, like I said, it was going up 15%, but this slide will help you know how much that is for each individual size unit. So the way this works is that these tables are very similar to the way the code tables work. You have to know if you're on an AC or heat pump first. You got to get the right tonnage range or BTU range for whatever you're looking at. This is 65,000, which is essentially 5.5 tons, right, up to 135,000. So AC, let's say it's a 10-ton AC unit. I'm in this category. This top row across here is if I have no heating system or I have electric heating, because electric heating is not very airflow restrictive. And then here is all other heating. All other means I have natural gas, I have propane, I have a hydronic coil, something like that, right? And those are the efficiencies that I have to hit today. So gas-fired 10-ton rooftop unit has to be 12.7 IER today, nationally, at the manufacturing level, and it goes up to 14.6, which is a pretty big jump there, right? Similar discussion over here on heat pumps. And then as you get to larger tonnages, same kind of thing happens. So these tables are here for you to have as a reference. If you need them, I can send them to anybody who wants. Like I said, on the gas side, it's going up to 81%. It's not a big, huge deal, but it does have to be paid attention to. Not by you, but by the person designing the equipment. All right. So that kind of summarizes us for the Department of Energy rule changes. I'm going to throw another quiz question up for those that are playing along at home. All right. Starting in 2023, the new minimum efficiency for the northern area for small tonnage systems will be 13 SEER, 13.4 SEER 2, 16 SEER, or 16 SEER 2. So while you guys answer that, I'm going to pull up my question box and see if anything of interest is here. Okay, I don't have any questions. So I'll take a drink. Then I'll take another drink. All right, I'm closing this poll in 5 seconds. 4, 3, 2, 1. 85% of you got it correct. 13.4 SEER 2 will be the new requirement. 13 SEER is the current requirement, so that's not correct. And at no point in time today did we mention anything as high as 16 SEER. So 13.4 SEER 2. All right, energy code updates. This one's a little bit harder to discuss because this is not as firm as the other two topics, which are refrigerant and Department of Energy changes. Click on this. Let's go. So this is kind of a little map. I stole this from Mia just to give you an idea of what the general picture is. This is commercial. Their website is a similar one for residential if you're interested. But right now for this general area, Illinois as a state is higher up in the adoption process for newer codes than some of the other states in the area. That's because Illinois switched to an automatic adoption process, I want to say like 6 or 9 years ago. So every 3 years, we automatically get a new code. There are some legal things that have to happen to get the exact date of that. That's why we don't know exactly when this goes live. Last time it went live, July 1st, 2019. So conceptually, July-ish of 2022 would be the next time we would do it. I don't know if it'll be a little sooner than that or a little later. Probably not sooner, because if it was, we would have already gotten the final notification from the state, which we have not got. So probably a little bit later than July is my guess. So sometime this year is probably when this happens. But we'll see, just to be sure. We'll be switching from the 2018 to the 2021 version of the International Energy Conservation Code. So some of the things that'll be changing, just to give you kind of a high-level picture. I'm going to skip the things that are not mechanical because this is an HVAC webinar, so I don't care about other stuff today. But there is other stuff changing too, right? So the lighting systems always are getting updated as part of these code updates. The building envelope, meaning windows and insulation and stuff like that, get updated, and other stuff. And then mechanical systems have changes as well. So one of the things that's changing that could affect some of you, not most of you, but some of you, is the climate zone maps. We've had these for years. They're in the ASHRAE standards and the international codes books. The one on the left is our current map. So if you're with me today and you're in northern Illinois, you're in climate zone 5. And then you're the right of this magical line here. So you are A, which means you're in the moist climate zone. So temperature-wise 5, moisture-wise A, you're in climate zone 5A. So for all the things in the code, you'd look to see what it says in the table for what 5A has to do. If you were in Milwaukee, for example, you would have been 6A today. Well, obviously, as you can see with the new map, that changes. Milwaukee now becomes part of what we have going on here in Illinois. Because of climate change over time, areas are different, right? So some areas like here and then whatever this little couple counties are here in South Dakota, they are now part of the southern region. You can see in Illinois, if you look, there's a couple counties here that were yellow for, and now it's slightly tweaked for a couple of them. Not the end of the world, just a couple changes here and there, but you'll have to know what climate zone you are in. Most of you, at least on the engineering side, you design stuff in all kinds of states, so you have to reference these maps to know what's going on. You just have to use the current map with whatever code is applying to you. So when we switch in Illinois, we'll go to the 2021 IECC and we'll have the new map. But if you're doing a project in another state, they're probably still in the 2015 or 2018 version of the code. You don't go to the new map, you use the old one. So that's just something to be aware of. Other stuff that's changing, envelope requirements improving. That's always constant. The ASHRAE 90.1 stuff, if you didn't know, ASHRAE 90.1 also comes out every 3 years. It is also an energy document. It's an energy standard, if you will, versus IECC is the energy code. But what IECC does, and they do this for other stuff, not just energy standards, they basically cut and paste stuff out of ASHRAE. ASHRAE has all the research going on. They wait for them to change something and they bring it over. And then they either make it in a more stern code enforceable language, right? Because ASHRAE is the engineering community and IECC is the code official community. So they make it in more enforceable code language, stuff that's easier to police. And then sometimes they also amend stuff. So Illinois, when they release their version of it, it'll look exactly like the IECC book. And then there'll be a page of amendments that go with that. And they'll say, yeah, we're doing everything in that book, except for these 6 things we decided to change because we think that we are different enough, we need to change them. So we know we're going to have the new 2021 code. What we don't know is what those amendments are going to be. That's what we're waiting from on the state to know what tweaks have to happen. So that one's still coming down the pipeline. In general, the whole code book, 2021 versus 2018, is an 8 to 10% efficiency improvement depending on the kind of systems, building types, and stuff like that you're dealing with. So it's another good leap, if you will. Just kind of like help you visualize it a little bit. This is where some of the things have changed. So some stuff you may not care about, like transportation energy or whatever. But some things we do care about, HVAC controls, HVAC efficiency. So we're going to highlight a few of those things here just so you're aware of them so you know they're coming. So the tables in ASHRAE 90.1 are basically all coming over to the IECC. So equipment efficiencies are going up. So just like the Department of Energy is making the equipment efficiency go up, the building codes are also making the efficiency of the equipment go up. And then some stuff which has been underrepresented in the tables, I'll say, is now getting a little bit better. So for example, VRF, it's been in 90.1 a few times now, but IECC has seemed to not want to bring those tables over. Now those tables come over, right? So you get those efficiencies on VRF system. So some of those special categories, dedicated outside air units, those are always kind of weird. Like, well, do I put it with the regular 10-ton, package system and try to figure out if it meets it? How is it going to meet it with all that outside air? So now it has its own, category, if you will. As the Department of Energy rules change, the codes will all at least be those new rules or higher in some cases. They don't want the rules of the state code to be less than the federal rules. That just makes things confusing. Other stuff that's happening, most of you have done or been involved with or aware of that we have fault detection and diagnostic requirements on economizers today. We've had those on the, past 4 or 5 years for the energy code. That means if the economizer has an issue, it has to self-detect the issue, actuators binding up, for example, and then report that issue to someone. Not just by turning on a light inside the unit that no one sees. It's got to send it to the building automation system, or if there's no BAS, send it downstairs and make it flash on the thermostat. So we have that on economizers for a while. And the reason we have that is because economizers are great and they save energy, but a lot of them fail and no one knows they fail because something else, i.e. the cooling system, eventually kicks on and makes up for the fact that the economizer damper is stuck, right? So it just gets kind of lost. So this is a way for it to be identified early on so we don't lose out on that energy savings. Well, that same idea, FDD, on economizers is now getting applied to the whole entire system. So lots of things in the system will have to have fault detection and diagnostic control on them to basically advise the building operator when something has failed behind the scenes. There's a whole document and standard on how that works, but that's coming down the pipe. Small buildings won't have to do it because it's not really practical to implement all those controls on a small building. But on a big building, you're already putting in a bunch of energy management BAS stuff. So now you're just adding features to that stuff. But like somebody's mom and pop restaurant, you were just going to put a thermostat in. So it wouldn't make sense there. Some of the small equipment, this is commercial right now we're looking at, but it's taking some of the tables we've already had for residential and bringing them over to commercial because people are using some of these small pieces of equipment in commercial buildings. So those low horsepower type things. Some scheduling stuff changes. The VRF one is a big one. The way it is today, if you put a VRF system in a commercial building, you still have to follow the rules for putting an economizer in. You don't get a pass on that. Now, most of you that have done VRF know that putting an airside economizer in a VRF doesn't really make any sense because you don't have any ductwork. So how are you supposed to bring in outside air more than the code outside air to get free cooling? It's not a good match. So what you have to do today is either A, don't follow code and hope no one notices, right? And feel good about yourself because you put in a really efficient VRF and it kind of made up for it. Or B, what you have to do is do the energy modeling code compliance path, where you basically model the building as if you built it to code. Then you model it again using your system, in this case VRF, and as long as you exceed it by a certain percentage, 15%, it's considered code compliant. That will no longer have to happen, and VRF will just automatically get an exception for not needing an air-based economizer. Demand control ventilation we've had for a long time in the code as well. It used to be 40, now it's 25, and it'll be going down to 15 people per 1,000 square foot. So if you have that ratio, 15 people per 1,000 square foot, then you'll be required to do demand control ventilation, which usually means CO2 sensors. That's the dominant way that we would do that normally. So that requirement will get stricter. So instead of it just being like conference rooms, it'll also include like some office areas and stuff like that, where you have a lot of people like sitting in cubicles near each other. Other stuff that's coming down the pipe that's more niche. Have to shut down the on a water source heat pump job. Have to shut down the circulating loop on a closed circuit cooling tower. Some exhaust fan controls required in parking garages that are different than our current rules. So there's just some stuff that's changing that's kind of super specialized. Additional control requirements for supplier temperature reset to factor in dehumidification which currently is not really involved in discussion. Some areas are more strict than others. You guys don't care normally about climate zones 3A and less. That's down south, so it doesn't really apply to you. But if you do a project out of state, some of this stuff starts coming into play. This one will affect you. Right now, ERVs are required for lots of types of projects whenever you have a certain amount of outside air, which is not very much anymore these days. You have to do these ERVs. One of the main exceptions to not doing the ERV today is if you have multiple exhaust fans for the building. Then you could say, well, I got all these little exhaust fans coming from each apartment, so therefore I don't have to do the ERV per exception number, blah, blah, blah. That's going away. And now that exception will not be available to you. So an apartment building complex will have to have energy recovery, right? You have all these little exhaust fans coming out. You'd be smart to combine them into one big centralized exhaust and run them through one big ERV. Or you could do a bunch of little individual ones. That's fine too. But you're no longer going to have the exception to get out of doing it for an apartment building. Apartment buildings, by the way, fall under the residential code unless they're like 3 stories and less. Or in some cases 4 stories and less if it's certain places like Chicago. Efficiency minimum is going up. Right now it's 50%. It's going to go up to 60% on the heating side. That's not a big deal because most ERVs can do that out of the box. So you have to look really hard to find one crappier than that. If you're doing chiller heat reclaim stuff, which we tend to do a decent amount of here at TEC, there's some additional requirements kicking in for that, specifically in relation to hospitals. Right now we do it a lot like on places that have swimming pools and stuff like that where you have simultaneous heating and cooling needed. But they're recognizing that in hospitals, there's pretty much reheat needed most of the year, if not all of the year. So they're requiring it more strictly in hospitals now than we used to have. I don't know anything about these 3. I just threw them in there because they were kind of mechanically related, but they have nothing to do with HVAC, but just more changes coming from you on things that are mechanical that some of you might get involved in. And I also don't have any experience really with data centers, but some of the rules are changing there as well for the energy code. And service water, same thing, not HVAC, but nonetheless, still typically designed by the MEP. So there's a new increase there on how efficient you have to be. All right, quiz question number 4. Doing okay on time, it looks like. All right, true or false? The equipment efficiency minimums of the IECC 2021 are updated to match the ASHRAE 90.1 2019 tables. Okay, let's see if you guys typed anything in. Nope, I don't have any questions, so we're doing good there. If you do have a question, type it in, and I'll do my best to try to answer it. All right, looks like 70% of you voted, so I'm going to close it in 5 seconds. 4, 3, 2, 1. All right, correct answer is true. 73% of you got that correct. The 90.1 tables get pushed over to IECC tables. Will, I see your question about the question, and the last question on today will be that same question again, which I realize just didn't help anybody else because we don't know what we're talking about. Okay. Last topic to rope in here is utility rebates. There's a lot of stuff going on there. Not a lot of changes, but there are some. So we'll try to summarize some of that stuff for you guys. All right, so start off with electric, with ComEd, because almost everybody, and by the way, I'm just doing this from an Illinois perspective. If you have other states you're interested in, I might know what's going on. I'm pretty good with Wisconsin and to a lesser degree, NIPSCO. But if you're like out in Nebraska, I don't know anything about that. But most of you guys, 90-some% of you guys on this call are from ComEd territory, so that's what we're going to cover. So commercially speaking, there are 2 main ways to get rebates for equipment. There's like 12 different rebate programs from ComEd, but most of them are special things. The 2 we're going to talk about here are standard rebates. So there's lighting versions of this as well, but we're focused on HVAC. So this is rebates for things like you install an economizer, you put in a more efficient rooftop unit, you add VFDs onto a pump or a fan, you upgrade your chiller plant, like that kind of stuff, right? Rooftops are actually available on this program and another program, which is why I put a note for rooftops on here. They're $12 per ton per IER above code. That sounds good and it's nice, but the other program I'll show you in a minute here is actually better from ComEd. Then there's also, in addition to equipment efficiency upgrades, there are things that are more, I don't know, what's the right word? Not equipment, I don't know. So you can upgrade your building automation system, and you can get rebates for doing that. You can get rebates for tune-ups, where ComEd will literally pay you to make your existing equipment more efficient. And then there's custom, and almost all the utilities have something for custom in pretty much every state, electric and gas. That means I want to do something. It's not listed in your program as a rebate thing, but it saves a lot of energy. Here's what I want to do. Here's how much energy I think it'll save. What do you think? You give me some money? And they come back to you with a letter saying how much money they're going to give you to do that. Essentially what it is, right? The other way to get rebates from ComEd commercially is what's called a midstream rebate. So standard rebate, the end user fills out an application and sends it to ComEd. Or more likely, the contractor engineer fills it out for the end user, has them sign it, and then sends it into ComEd. The midstream rebate is much different. The end user is not involved in this in any way. I mean, they're the end benefit of it because they get the more efficient thing, right? But the rebate money doesn't go to them. Technically, rebate money goes to us, to TEC. And then what we do is we're passing it on to you, the purchaser of the equipment, so HVAC contractor. So there's different dollar amounts there, but just to compare it to this $12 per ton thing, it can get pretty substantial on here. So it's not as much as it used to be last year, but it's still really good. But let's look at chillers first. I mean, we can look at each one of these things and spend 10 minutes on them, but I'm going to look at chillers and rooftops specifically today. So we're going to focus on. That's where some of the things are most changed compared to last year. So this is kind of a summary of all the main rebates that are available from ComEd commercially for HVAC equipment. There are two ways to get chiller rebates. You can do this air-cooled and water-cooled rebates up here, where you get X amount of dollars per ton per IPLAV improvement. Or if you have a chiller that has a VFD or a mag-bearing compressor, then you can just skip all of that math and go to this much larger dollar amount of $100 per ton on a VFD chiller or $200 per ton on a mag-bearing chiller. And I'll show you the specs on that here in a minute. And there's all the rebates for the various, smaller types of equipment, economizers, demand control, ventilation, CO2 sensors, that kind of stuff. VFDs, right? VFDs is a good one, $90 per horsepower. That's a nice rebate. Geothermal, changing out to different style belt on your fans, all that kind of stuff. And then down here where it says DX tune-up, if you have a DX system, rooftop or split, then you're eligible for some of these tune-up things. One of those things, and there's descriptions on what's required on these, but essentially what a basic tune-up is you're cleaning the condenser and evaporator coil. It's essentially what it is, right, along with some measurements. And then a full tune-up is that same as the basic, plus because of the measurements you made, you realize you needed to adjust the refrigerant charge, and they give you more money for that. You can repair an existing economizer and get it working again. Something like 70% of economizers in the United States are not functioning correctly, so there's a lot of ability to improve efficiency by making that thing work again. The same V-belt thing happens to be down on the tune-up program. You could do advanced rooftop controls, which is a controller that does variable speed fan control, or not even that, staged fan control, staged air volume fan control, economizer and CO2 combo. And you can also add smart or programmable thermostats. If you look at the chiller specifically for the big chiller amounts, the $100 per ton VFD chiller and the $200 per ton for the mag bearing compressor based chillers. These are the metrics you need to hit. You can do either path A or path B, just like with code compliance. There's a path A and a path B. You can do either one of those and be above that to get these dollar amounts. And then the nice thing about this versus last year was the first year they had this. The nice thing for that last year was it was a bigger dollar amount because it was kind of like a test run thing. But the bad thing is it was really restrictive. Only certain kinds of buildings were eligible. It was difficult to use it on multi-chiller plants. So some of those rules have loosened up, and now even though the dollar amount is lower, you're able to do it on more types of buildings. The thing I will mention with this is chillers obviously have a pretty long lead time, and this program ends in October, I believe it is. So this is pretty much for stuff you're thinking about like ordering like now, like this is right now kind of thing. If not, you're thinking about next year already, and that's a different program. If you're doing the midstream stuff, that's where ComEd doesn't get an application from you. They don't give you any money. Instead, they give TEC money for selling high efficiency things in their area. And then we have chosen to give that money to you, right? Obviously, ComEd encourages us to give it to you because the idea is to drive behavior here. So this is for rooftop units, in this case, gas-fired or electric-based rooftop units. You can do tier 2 or tier 3, which is part of the CE designations. But essentially, you need to hit these efficiency minimums for those size ranges to get this money. That's basically what it is. These minimums are all above code. They're more similar to Energy Star type values. There's no full load requirement. It's part load. Part load meaning SEER for little stuff, IER for big stuff. For that size, if you got a 10-ton unit, boom, and you can beat 14 EER, they give you $56 per ton. So $560 some, right? There's also a tier 3. That's significantly more difficult to reach. So not every single size and every single model will have an option for these, but there are sometimes you can get to these. These ones are doable. Like pretty much everybody's got something that could do this, but these ones are harder, and you might or may not be able to get there with a certain type of unit. And then also part of that program, there are air source heat pumps on there. So it works the same way, hit a certain efficiency rating, get a certain dollar amount. And then if you're doing stuff that has P-tax, which is usually hotel work, but not always, there are rebates for P-tax on there as well. So the way this works is you would basically work with TEC. We would help you calculate how much rebate you're going to get. So we're working with ComEd on the backside. And ComEd, after the job happens, is going to give us the money, and then we're going to give you the money. And then you could pocket it as the contractor, or you can use it to give it to the consumer to get them to buy the more efficient thing from the very beginning, right? ComEd doesn't really care who gets the money in this case. They just want someone to do the more efficient thing. And whether they got to pay us, you, or your customer to make it happen, that's your choice. For all these programs, you need to be ICC certified, which has nothing to do with the IECC Energy Code. This is Illinois Commerce Commission. And for this electrical type work, for both ComEd and Ameren customers in Illinois, or not customers, contractors, I should say, the contractor has to be ICC certified. It's not difficult to do. It's basically a bunch of paperwork showing that you have the right insurance and all of that. And you have to renew it every year. So make sure you don't forget to do that, or you will not be eligible to offer rebates to customers. Just to give you a snapshot of some of these rules side by side, in this case, based on rooftops and based on tonnage, I'm going to stick with the 10-ton example we had before. Here's the current code minimum for building code minimum, which is statewide in Illinois. Here's the minimum federal efficiency. There's no ER minimum. Do whatever you want on a full load. Part load is very similar. In most cases, it's the same, but in this one, it's 1.1 off. So you're wondering, like, why is there this and that if it's the same thing? This is your building code. This is the federal manufacturing standard. If the building code's all updated nationally at the same time, you really wouldn't need this. It would just happen. But unfortunately, that's not the case. And there's only 12 or 18 states that are on the new energy code. So the federal minimum kind of pushes it along, at least from an equipment standpoint. Here's the Energy Star rating. Sometimes there'll be certain programs that say you have to have Energy Star requirements to get certain grant monies or something like that. So that's what those would be. Energy Stars for smaller stuff only. And then here's the regular ComEd rebate you have to hit. And if you want the big dollar amount ComEd rebate, it's here. And I probably should add a column for tier 3 to get the even bigger ComEd rebate for a rooftop unit. For you guys that are residential, because I know there's a few of you guys on there, nothing has changed residentially. It's exact same as last year. It's also a midstream program, which means the rebate money comes to TEC. We issue it out to you. You can either keep it or you can give it to your consumer, probably give it to your consumer in order to make the project happen. Hey, if you go to high efficiency, we can get you $400 on your heat pump or whatever the discussion is. So those are the dollar amounts down here, right? It's less for AC. It's more for a heat pump because A, heat pumps are running in 2 seasons, right? Or 4 seasons rather instead of 1. And then B, heat pumps, there's a big movement to get everything off of big movement nationally, let alone statewide, to get everything off of fossil fuels and onto electric, so that way it can all eventually be powered by renewable electric. There's ductless mini splits on here for residential as well. That's a pretty good rebate on there. And it's really easy to get to 17 SEER on a ductless mini split, because those things are typically like 20 something or more, 40 in some cases. There is regular rebates still available from ComEd, but not for those kinds of equipment. The only way to get a rebate on this equipment is to go through the distributor. And then oddly, the only way to get rebate for this is to fill out the old school application form. So geothermal, which you have to be a qualified contractor to do. Certain contractors have to only can offer that. The tune-ups, anybody can offer. That's a contractor, as long as you're ICC certified. Smart thermostats, AeroSeal for your ductwork, that kind of stuff. Nothing's changed on either one of these. Same, no changes. People's North Shore Gas, there's minimal changes on the commercial side there. These are domestic water related, so I don't even really know what they mean, because I don't do that kind of work. But I'm just kidding. If you've reduced the flow, you'll reduce the amount of gas needed to heat the water, obviously. So that's why there's these flow restrictors, specifically for hotel type projects on here. Some other changes that have happened. The tune-up program has expanded more. So not only just boilers, but you can also do it on furnaces and rooftops in commercial buildings now. So you could have a rooftop unit, get paid by ComEd to tune up the cooling side, get paid by the gas company to tune up the heating side, and kind of double dip on that discussion. Other stuff, domestic water we were kind of talking about, steam traps they've always had, but some changes there. I just put that on here for your reference. I'm not going to go through all of those individual widgets. If you're doing big stuff like a boiler replacement, nothing has changed there. It's the same deal. Depending on the size of the boiler, determines which form you fill out, but it's all the same. $1.25 per MBH input, which is really attractive dollar amount. You can get a lot of money this way from them. And steam boilers have a little bit less dollar amount because steam boilers are not as efficient as hot water boilers. Here's the tune-up stuff I was talking about. So there's boiler tune-ups on here, and there's also furnace rooftop tune-ups that were added on here. So you can get 30 cents per MBH input for any kind of space heating thing, furnace, rooftop, boiler. If it's processed, you can get even more because obviously you have more run hours typically. If you're doing residential stuff, People's North Shore, basically no changes there. Like everything's pretty much exactly the same as it was last year, so nothing to freak out about there. If you knew what was going on last year, you know what's going on this year. So furnaces, boilers, combination units, indirect tanks on your boiler, smart stats, etc. Duct sealing also available. So if you're doing duct sealing at a house, you can get the $200 from ComEd and the $400 from the gas company and double dip it. So there's that option there. If you're doing commercial stuff with Nicor, which is everything that's pretty much not People's in North Shore, there's pretty much no changes. Like Nicor made my life easy and everything's pretty much exactly the same as it was last year. Once again, though, they have rebates on boiler replacement, furnaces, infrared heaters, condensing unit heaters, all that kind of stuff, programmable thermostats, all that kind of stuff. So no changes on any of their program stuff commercially, all the same. Only that changed that looks like the checklist for the boilers, but the actual dollar amount didn't change, so all the same. They did add this. I don't know who replaces boiler radiators, but if you did, you can get a rebate for it. And then also boiler descaling, you could do a rebate for. Those are new. And then some non-HVAC stuff is new, overhead doors, and then pipe insulation, some changes happening there. It says to be determined over here, and then I put the changes over here. This was old, this is new information. And then obviously custom for all the gas companies as well. Residentially, if you're doing Nicor, furnaces and boilers, no change. Same dollar amount, same efficiency tiers. They added tankless water heaters and combi boilers. Those are new. Smart thermostats, no change. That's another double dip opportunity. You can get money from ComEd and money from Nicor on the exact same thermostat and double dip the gas heating and the electric cooling savings rebates on there. If you guys do residential, these stats in the bottom don't qualify for ComEd, but they do qualify for Nicor gas, whereas like an ecobee qualifies for everything. And then some tweaks over here on some of the weatherization rebates. So like duct sealing, once again, $400 plus 200 from ComEd, 600 total you could do on AeroSeal duct sealing. All right, quiz question number 5. I'm like running out of time here, so let's get them knocked out. 2 more questions. I'm going to do them right back to back here. Which are ways to claim a ComEd commercial rebate? I guess residential would be the same answer. So it doesn't matter if it's residential or commercial. Let me see if anybody typed a question in. John asks, what's the new Freon for R410A? It will vary. So each type of equipment, chiller, rooftop, residential split, and each manufacturer may be using something different. So if you're talking about, say, for example, residential like commercial with Carrier, we use 410A now, and we'll be switching to 454B, 454-B. Some manufacturers are not doing that, and they're going to R32. Some manufacturers are doing a different 400 series level refrigerant. So it'll get confusing and sloppy for everyone in the field for a little bit as you figure out what the hell's going on with each manufacturer and what color stickers apply to what kind of refrigerant. So you just have to pay attention for a while until we have, something settles out in the marketplace. All right, I'm closing this question in 3, 2, 1. Looks like 88% of you got it correct. You can do standard or midstream rebates. It depends on what we're talking about, what kind of equipment you're dealing with. All right, last quiz question here. Maybe, if I can click on it. Dude, come on. You're killing me, Smalls. Okay, let's see if this pops up. Do you need a PDH certificate for PE license? Yes or no? You can't get it wrong, but you do have to answer it. Eric asked if you can mix refrigerants like a top-off from old and new. I don't know any manufacturer for current stuff or past stuff or future stuff that allows that. In reality, could you do it? Maybe, if you got refrigerants that have similar properties and you're aware of the properties. But generally speaking, no. I'm not sure why you would want to mix refrigerants either. I don't know. I mean, that would be just use the right refrigerant, I guess. Other than you don't want to carry a bunch of different types, obviously, on your truck. But so the short answer is no. You shouldn't be mixing refrigerants. But if someone's going to do it, maybe they would. I don't know. Tess actually asks, what does PDH stand for? It's Professional Development Hours. It's just the verbiage that engineers use for their license requirements in Illinois. It's kind of a specific version of a CEU. Eric asks like MO E99 or R22. So that one is a refrigerant specifically made to be an R22 replacement. But you wouldn't want to take that and put it on top of, say, 410A. It's a different refrigerant property. So, but MO99 has been designed to be as similar to R22 as possible. However, once again, most of the manufacturers do not permit you to use those drop-in refrigerants. But at that point, anything that's R22 is out of warranty, so you probably don't care what the manufacturer says. Bryant says refrigerants aren't glycol. True. I don't know what that has to do with what we're talking about, but that is true. Eric asked if there'd be an R410A replacement. I haven't heard about anything, but those manufacturers of refrigerants, I'm sure, are trying to figure something out on something that's similar to 410A, but has a lower global warming potential. But as of right now, have not seen anything from the Honeywells or DuPonts or any of those kind of guys of the world. Let me close this question here so people that need to leave can leave, and then I'll answer some more questions. All right, closing the poll question. All right. John asks if you can use 454B on 410A residential units. No, you cannot do that. Refrigerant properties are different enough that it will not be acceptable. Plus, 454B has a different flammability rating, so it's not even going to be approved to be put into something that wasn't designed for that. So no, you can't do it. Once again, you can do whatever you want. You can stick anything in anything. That sounds bad. You can put on your refrigerant in anything and hope for the best, but it's definitely not something that would be approved by any manufacturer. All right, I know it has a lot of stuff. What else? Why's my slide thing not showing? You guys can't see my slides, can you? Do that, share, hide, and then let me do this. Okay, there we go. All right, so that's my email if you need to hunt me down for any reason, or if you want me to send you something that you're looking for, one of the specific screens that we showed today or a table or something, let me know and I'll try to send it to you. Like I said, there's 200 plus of you on here, so I probably won't get to you for a few days if you send me something, because I already saw a crap load of emails come into my phone from people. So it might take a little bit, but I'll get you whatever it is you're trying to. Oh, someone said the email cut off on the bottom of the screen. Wonder why that is. It's showing on my other screen, but let me see here. Let's do this. There. Now you should, hopefully it's where you can see it now. It's also my way not to help anybody. If I tell you to send me an email and I don't give you my email, then I don't have to help you. No, I'm just kidding. What else? Any other questions anybody wants to answer before we cut off here? We're 7 minutes over, so we probably should get ready to shut it down. So if you need something else, hit us up and we'll do our best to help you. And thanks for joining us today.